Hey folks, my name is Kyle Teagarden. I'm a senior product manager here at Microsoft for Azure Cache for Redis specifically. And my presentation today is about getting real practical. We have all heard a lot about AI and the many benefits of AI, but what does that mean in reality? So you've probably seen all the highlights. You've probably used ChatGPT. It is legitimately awesome. AI is going to change the world in one way or another, but there is a lot of hype. Will AI cure cancer within 5 years? Maybe not. What does AI actually mean for you and your applications and your businesses right now? So you may have seen this post. It's a few years old now about ML is written in Python, AI is written in PowerPoint. There's a little bit of truth to that, right? Like people talk about these things like they're around the corner, but it's important to actually get down to brass tacks and understand what you can and cannot do with AI and languages like Python today. And so my objective in this presentation is to get down to ground level and understand, all right, if you're going to build an AI-based app, what is your toolkit? Like what's the stack? What are the Python libraries you should be using? What are the practical steps to make this a reality? And how would you actually go about deploying the application on Azure? So this is meant to be for people that have heard about AI, maybe have some skills with Python and want to understand how to get started. And so the goal of this exercise is to build a movie recommendation app. So I want to be able to input a phrase or a description of a plot or just keywords and then get an output of a movie recommendation and a score of how closely it matches the input. And if you kind of see this, you're familiar with some of the latest AI stuff. This is a vector similarity search use case. So in terms of theory, it looks kind of like this. So if we go on the conceptual AI side for a second, there's a bunch of different ML models, right? You might be familiar with some of the text generation models and things like ChatGPT, which are available right now on Azure OpenAI service. But there's models that are kind of a layer beneath that into this concept called embeddings. And the idea here is that you can run text, and in some cases, video or even audio, almost anything through an ML model called an embedding model. And you get an output that's a vector of basically like an n-dimensional unit vector of various different magnitudes. So you can see an example here. If I put the text spaceships, aliens, and heroes saving America into my embedding model, I'll get this 1,536 dimension output of that many unit vectors with slightly different magnitudes for each of them. And based on the magic of your ML model, that vector output will be different for every different block of text you put in. And we don't really know what each dimension means, right? Like one way to think of it is if there was just like a two-dimensional vector, then you could have like a vector for spaceships and a vector for America. And a movie like Lincoln would fit very much on the America side, so maybe a large magnitude for the America vector, but a very, very small magnitude for the spaceship vector, where a movie like Star Trek II, The Wrath of Khan, great movie, would have a pretty high magnitude for the spaceship vector and a very low magnitude for the America vector. Maybe a little bit greater of a magnitude for America than Lincoln would have for spaceships, but pretty low there. A movie like, say, Independence Day, the classic from 1995, I believe, has a little bit of spaceships and also a little bit of America. And so that vector is somewhere in the middle. And what we can do is we can compare the vector for our query about spaceships, aliens, and America with the vector for the plot summaries of different movies and compare the distance between them. And there's a whole bunch of different ways to compare the distance in Euclidean space by using a cosine, which is maybe the most popular, et cetera, et cetera. And so this is like a really interesting and kind of elegant way to compare two bits of text or two bits of media together without having kind of a defined schema around those bits of text or media. And so the challenge here is, all right, we need a way to generate the vectors, we need a way to store the vectors, and we need a way to compare these vectors together. So that takes us to this application. I see some love for Star Trek II in the comments, completely agree. I'll also mention if you have any questions, please put those in the chat at any point during this presentation. I'll try to watch the chat and address them during the presentation, and if I don't, we'll get to them at the end. Okay, so this is kind of our general AI concept. What does this look like in practice? So this is what we're going to try to put together. We're going to take a data set that's from Kaggle, great resource for different ML learning data sets. We're going to ingest that data set into pandas, which is our beloved Python framework. We're going to use langchain to tie multiple different services together, which is this really useful integration kind of library for ML applications. And then we're going to use Azure Cache for Redis, specifically our enterprise tier, to be our vector DB. So we're going to store our vectors there and use it to do the searches as well. And then, of course, our good friend Azure OpenAI service to generate the embeddings. And then the UI and the application itself will run in this framework called Streamlit, which is a way to make these really simple applications all in Python. All right, so let's break this down step by step. The first step is the data set. This should be pretty familiar for folks. I found this great data set on Kaggle that is the descriptions of the plots for 35,000 movies from Wikipedia. So it's a pretty solid data set. We have some good metadata there. Here's the top items in the data set, right? So the movies go all the way back to 1901 and ends in 2017. And this is great for us because we can generate our embeddings on the plot column, and we can use the other data for filtering, which I'll explain a bit later. Step 2 is we will ingest and clean that data. And I will mention that I got the code here up in the PowerPoint slides. I do have a link at the end to a repo with a Jupyter notebook with all this step by step, and also the application I'll be showing at the end as well. So if you've used pandas before, it's awesome. I refer to it as kind of like Excel and Python, which probably really upsets people that are both Excel power users and also pandas power users, but it's a great way to organize and structure data in Python. And so this lets us do things like we can filter the number of years, like take only movies from after 1970 or only English-speaking movies. And then we can also clean the data, right? So we want to clean the data both for clarity and for our embeddings model. We don't want to pay more than we have to embed empty spaces or extra periods, that type of thing. All right, so pretty simple to do that in Pandas. And then we set up our embeddings model in Azure OpenAI. So this is as simple as going to Azure OpenAI, just creating an embeddings model. It takes like 5 seconds. And then all you got to do basically is put the information into langchain. They have an object for OpenAI embeddings. And we just send in our information on our deployment model name, the endpoint, and your connection key, and you're connected. So it's really easy to set up using langchain as kind of a platform or a layer in between. And then you need a vector database. And if you can see my little title on the screen, I am a product manager on the Azure Cache Redis team. So if you'll indulge me, I will take a few extra moments to talk about using Redis as your vector database, because this is a really important part of your application. So if you don't know about Redis, it's a very, very popular open source in-memory data store and cache. It's used everywhere. It's really flexible. And we have a managed version of it on Azure. It's called Azure Cache for Redis, which is just taking that goodness of Redis and then adding some more powerful features like active georeplication and also support for the Redis stack, which includes functionality like vector search. And then we also add some reliability features, right? So if you deploy all this to production, it helps to have automatic failover when you're doing patching and scaling support and can actually back SLAs. And then there's this functionality that's built into Redis. It's part of the Redis search module. I think it's been renamed now to the Redis stack. And it's been around actually for years. It's one of the most mature vector DBs and vector search kind of platforms. And so it offers a pretty rich feature set to index your vectors and also to compare the vectors. So you can use a couple different ways. HNSW stands for, I think it's hierarchical navigatable small worlds, if my memory serves. It's basically an approximate nearest neighbor. So it'll give you the nearest results, but it's not perfectly precise, but you get a little more speed from it. And then also a flat index method. which is more kind of rigorous, but takes a little while longer. So you have a performance precision trade-off. So Redis supports both, which is kind of unique. Most support one or the other. And then 3 different distance metrics for measuring the distance between those vectors. Like I mentioned, cosine, I think, is the most popular at this point, so that's what I used in this demo. And then the really cool thing about Redis is that you can actually do more than just vector comparison. So I mentioned metadata. You can use that metadata and do a lot of pretty rich search queries on top of your vector search, because Redis has all this built-in Redis functionality. And Pamela, to answer your question, the Q is meant to be an eyeglass kind of thing. So it's just an abstract representation of Redis search. Yeah, so it's more than just vector search, right? It's also this kind of rich search with all sorts of functionality around geo search, text search, fuzzy match, pretty much anything you're looking for from a search standpoint is also available in Redis. And then the other really good thing about Redis and using it for vector DBs and vector search is that it has a lot of great integration. So there's a really rich integration with LangChain, which I'm using in this demo, and is a very popular way to do a lot of these applications. So you get a lot more functionality and documentation with Redis than you might with other vector stores. And also, Redis has been around for almost 15 years at this point. And so there's a lot of examples on how to use Redis and get started, and other libraries and integrations to use Redis for other things. So if you're using Redis as a cache or as a session store, it's easy to also use that to do to store vectors and to search vectors. Cool. All right. So what does this actually look like in Python? Here's an example. We just import a couple libraries from LangChain. We load our data frame in 2 lines of code into a LangChain concept called a document, basically. We set up our URL to our Redis instance running on Azure, or if you're running on-prem, you could still do this on-prem. And then we set up our vector store. We basically just pass in our documents from pandas, pass in the reference to our Azure OpenAI service. We give the name of the index, and we give the link to Redis. And that little block of code will take all of your documents from pandas. It'll take the plot column, which we specified, generate embeddings in all of those by handing them to Azure OpenAI, and then store all of those in Redis in a hash data type. So it literally does all of that for you, basically, which is pretty nifty. And I'll actually show you real quick. Check time. This is called Redis Insights. It's the desktop application for viewing your keys in Redis. And so this is just an example of how this works, right? So for example, here's we're looking at our movie index here. Each of these are an entry in Redis, basically 1 per movie. And you can see the different values, right? So we have the year, we have the Wikipedia page, we have things like directors and actors, origin, and the plot. And then this here is the vector that was generated. It's in bytecode, so it's not human readable. But this was what was generated by Azure OpenAI and then stored in Redis. So you can kind of see what's going on behind the scenes. All right. And then when it comes time to search, that also is pretty straightforward, surprisingly easy. All you do is you call the vector store similarity search function, put your query in, and then you get your answers. And you can ask for as many nearest neighbor results as you would like. So example here, right, if I search for alien spaceships and heroes saving America, it tells me Independence Day is the closest match with a distance of 0.1652. And the really cool thing is, since Redis has all this rich search functionality, you also can filter on things. So in this case, we have metadata on genre, so we can filter based on the genre comedy. And in this case, you see that we get the result Remote Control, which is a movie from the 1980s that I have never seen, but is, I guess, a comedy that involves like aliens coming to America. So it like triggered on some of those words. And you'll see that it's still pretty close, like it's not that far away, but it's a little further away than Independence Day is. And that's because that vector distance is just a little bit further, right? Some of those vectors don't align quite as well. Okay, so this is what that looks like. To show you what this looks like in practice, let me pull up Jupyter Notebook. And Again, this is in a repo. There's a link at the end of the slide, so you're welcome to try all this out yourself. It's all kind of set up. And you can see this is exactly what we did. So we're getting our CSV, uploading that into pandas. We have our data here. We're cleaning it to only take more recent movies. More cleaning of the data. We can generate the number of tokens to calculate the cost. So in this case, we're running at about 7 million tokens. And I forget the latest pricing, but I think that's about 50 cents to generate all of these embeddings. Loading it into langchain, we have our Redis instance. That's actually just kind of for testing. Here we have our embeddings that are being set up, our Redis instance that's being set up, and then this will load our embeddings. And then if we want to see what this looks like, we can just run this, right? So running that query, get our title, Independence Day, and distance. I can change this to whatever, right? I can say a cute movie about dogs and kids playing basketball. And we run this, and we get a movie all in good taste. Not familiar with that movie. Or, for instance, cartoon characters playing basketball against monsters with NBA players. It's a pretty specific vector, and we get Space Jam as our output. So this is kind of fundamentals of how all this stuff works, like in real world, and it really isn't that crazy. It's not that many lines of code to get some pretty powerful results from this, because there are existing Python libraries that abstract a lot of the details under the scene. All right, so let me jump back to this slide. All right, so that gives us kind of the core of this application and how this all works. The next step is to add a UI. How do we make this like a real application and not just in the command line? And I stumbled upon this really cool framework called Streamlit, which is all in Python. And it's a really easy way to create some pretty rich user experiences without having to learn a bunch of JavaScript or React or anything like that. So the code over on the right, that literally creates the experience that you see on the left. Right, it's really straightforward, all in Python, easy to get started. So it's a great way to do testing and prototypes of an application, especially a machine learning application. I think the caveats here are that there's like a pretty good selection of different UI elements you can use, but there's not a lot of customization you can use. So maybe not the best for a production application, but a great way to test things out without having to have a ton of front-end knowledge. Okay, so we have all this stuff. We have our data set. We've got everything in. We're using langchain to put everything together. We have our UI with Streamlit. We have our application set up. The next step is just to deploy that to Azure, right? So Azure OpenAI and Azure Cache Redis already running in Azure. That's easy. And then all we got to do is take the middle piece, throw that into a container, and then deploy that container to Azure Container Apps. And so that's exactly what I've done. And you can see that if I go to my web browser. Here you go. So I got all the different components here. I got Redis, I got my OpenAI service, and then I have this container app that's set up. And the really cool thing here is that there's a command called Azure Container App up that you can use, and that'll basically take your Docker file and do all the steps required to deploy that into a Azure Container App that's ready to go. And so it literally is a one-line command to get everything going. And if I go there, you can see that it's all running, no problem. I can go to the application. And this is actually live on the public internet. So if you want to give this a try, feel free to go ahead and do that. And I can do my search. What was my specific query? It was copy and paste it. Yeah, spaceships, aliens, and heroes saving America. So I can do this, boom, hit enter, and it gives me Independence Day, and it gives me the score. This is actually an inverse score in this case. This is vector similarity rather than vector distance, but same thing. And then it gives us other examples here too. And I can actually go all the way up to the 10 nearest neighbors, search for that, and we get a whole bunch of different options here. So, we get things like Exogenesis by James Cameron and The Flying Machine, so on and so forth. And if people have any question or any suggestions on queries in the chat, I'm happy to try those out too. It might be the same as AZD up. I actually don't know, Sarah. That's a good question. It wouldn't surprise me if there's an AZD command that makes kind of abstract all that. And then you can see here too, talked about additional filters. That all can be done through Streamlit as well. So I can filter the years. So, if I, like, for instance, let's do a test. If I limit this to just 1977, we might see something like Star Wars come up. Let's see. I get Starship Invasions in 1977 is the closest example there. Yeah, there's a lot of weird movies here. Yeah, so and Star Wars shows up there. And you can see that the more that I filter these results, the lower the similarity score is, right? So like if the best score from all filters from all these years was like a 0.84 similarity, and something from, if I limit it just to 1 year, we go down to 0.81. I can limit this further, right? If I say like drama, for instance, it's kind of a weird query. The score is going down further. And so some of these movies, they probably have nothing to do with aliens or spaceships, but maybe the vector is triggering more on America than the other ones. So just an example of kind of the fun things you can do with this. Okay, so this application, like I said, is live. Feel free to go ahead and give it a try. All right, and that was the demo. So just going over a few of the use cases, I said this would be a practical AI application. I'm hoping the instructions are very practical. Obviously, I'm guessing most people on this event probably don't have a pressing need for a movie recommendation or a movie similarity application. But you can see that there's a lot of applications that are similar to this that could be useful. So visual search is a really great example where you don't have to just use text for your embeddings models. You can use, like I said, audio or pictures. The Azure OpenAI embeddings model is just for text right now, but there's a whole bunch of embeddings models from different, different companies or vendors. Like you can use Llama or Hugging Face, and langchain makes it really easy to plug and play different models in. So if you want to swap your model out, you just swap it out in langchain, and everything else should work as expected. Semantic search is a really good example here, and so you see a lot of companies that we talk to that they, for example, have like a really complicated internal document for their like healthcare plan. We have that at Microsoft. It's 200 pages, and so I did a demo where you throw that into this same type of application, and you can ask a question, and it'll find you the paragraph or chunk of information in the complicated document that's most relevant. And you even can use the different text models from Azure OpenAI to summarize that data and make it even more convenient. So it's kind of like Q&A bot style application on custom data sources is another great application here. And then the last is just recommendation, right? If even if it's not a consumer application, it's still helpful to have searches to recommend products or applications or new features. And this is a great way to do that using AI. Awesome. In terms of next steps, like I mentioned, that repo at the top has the code from the application and also the Jupyter notebook. So if you want to get started, that's a great way to give things a try and get going. There's a couple other examples linked there of other similar applications that are good to start with. And we have a blog post that talks about this in some more detail too. So all ways to get started, learn more about vectors, embeddings, and using Redis as a vector data store. So I think we have a few minutes left. I'd be happy to take any questions you all would have.
That's awesome.
Does that work, Haley?
Yeah, Pamela just added another question here. How would you compare Redis vector search to Azure Cognitive Search, which now has vector support, of course? Yeah,
no, both awesome services, right? All part of the same Azure family. I think, to be totally transparent, the advantages and disadvantages of Redis, I should say, first of all, a lot of the same features, right? So a lot of it kind of comes down to what are you already using? What are you familiar with? There's not like a clear winner or not here. I think the advantages of Redis is that it does support flat indexing, which I don't think Cognitive Search does yet. And it's GA. It's just been around longer. And so there are a few things that maybe are a little more battle hardened or there's like more integration support in some ways for Redis than there might be for cognitive search, just because it's been around a bit longer. I think the other advantage is if you're already using Redis in an application, it's easier to get started with Redis because you already have it there. It's not hard to add vector capabilities to it. I think the disadvantage of Redis is right now it's only supported on our enterprise tier, and so the price point to get started, if you're not already using Redis, might be a little bit higher. And I think cognitive search has some really awesome entry points, and maybe even a free tier you can use to get started. So, both awesome things worth checking out. I think a lot of it comes down to kind of your personal preference.
And of course, we got to call out that Azure Cache for Redis also has a community stand-up. I know I've been plugging these all day. That's the 4th Tuesday of every month. And so I think the next one's on the 26th of September. So you can learn lots more. I'm putting the YouTube link again below here. And so subscribe to get notifications as these community stand-ups are coming up. And so, yeah, Kyle did a great intro into what is Azure Cache for Redis. And you can learn plenty more about that on the 26th, and then every 4th Tuesday of each month after that. But yeah, this was such a great session. I know when I graduated in, I think, 2018 with my CS degree, I didn't learn a lot about AI. I didn't take many classes on AI. So just thinking about all of this new AI stuff coming out, and everyone, it's the craze. It's the newest thing. It's a little daunting, and I was a little worried. I didn't know if I was going to be able to get on board, but hearing you talk about it, hearing all of these sessions, I realized it's completely in our grasp, but we have all the tools to learn it, to make it awesome. Yeah, I'm ready to get started and get learning. This has been super cool to hear about this. So thank you so much, Kyle.
Absolutely. And if there's one thing people take away is that it's a lot easier to get started than you might expect.
Yep. Yeah, on that, please do the cloud skills challenges. I'll plug that again because there's an entire challenge on AI and machine learning. And so if you want to figure out how to get started and what to do, it's laid out there for you. It's an easy stepping stone to get started. So always going to keep putting that link down there to get started. And there's also cloud skills challenges for if you're a beginner and you just want to learn Python. So any level you're at, come learn how to develop on Python, come learn how to do AI. And it's all right there laid out for you. We love to give action items so people can convert this into their real world scenarios. But thank you so much, Kyle.
Awesome. Thank you all.
Yeah. I also got a lot of great movie recommendations out of that. And a lot of them I hadn't seen. So yeah, in addition to learning AI, I've learned a lot of movies that I need to start watching.
If you haven't seen Independence Day, it is a true classic. Although it's not as good of a movie as Star Trek 2. So, there you go.
But I'll definitely look this up. So thanks so much, Kyle.
Perfect. Thank you all.